Welcome back. Unit 7 now. Woo! Logarithms. You got your logs? We gotta burn that logarithm. We gotta burn those logs. Bring your logs. Gotta learn about logarithms. So logarithms are the way that we can change our 10-base counting system into computer language, which is a 2-base counting system, right? Zeros and ones on and off switches. And so, yeah. So logarithms are pretty awesome. Let me show you what else is awesome that I got. And that is a floating, hovering world. I don't know if you can see it. Yeah. Look, it's like floating, hovering. Whoa, that's crazy. Whoa. So are you floating or hovering? Okay, let's see here. So we're helping you on Unit 7.1, which is graphing exponentials. Here we go. Okay. So good practicing, factoring, solving, number 1, number 2. That's pretty good. So don't forget how to factor. So give those 2 a try. Factors of 2 are 2 and 1. But what are factors of 6? Maybe 2 times 3? Yeah. And so we want a positive 2 times 2 is 4, and then minus 3. Nice. Ooh, what about this kind of factoring? That was number 1. What about number 2? Is that a perfect square? What does that factor into? Oh yeah, it's a difference. It's a difference of squares. They're perfect squares. So what does 100 factor into? 10 times 10? What about 49? Opposite signs, right? Opposite signs. Don't forget how to solve radicals. We learned that last unit, right? Don't forget to pause me and try it on your own. Wait, I'm waiting. Pause me, try it on your own. So we minus 13 over to the other side. And that's actually a 24 there is what we got there. And then we divide. Divide by negative 2. So is that a positive 12? So we get 24x is equal to 12. And then we still have the square root going on. So we have to power 2 both sides. What's 12 squared? 144. And then we divide by 24. So what's 144 divided by 24? Any guesses? Any guesses? 144 divided by 24 is 6. So we get x equals 6 as our answer. So let's see if it works though. Make sure you plug it in. Make sure it works. Make sure it works. So 6 times 24 is 144. So that's 144 plus 13 is equal to negative 11. And 144 squared is 12, so we have negative 2 times 12 is negative 24 plus 13. And what is negative 24 plus 13? Should be negative 11. Way-o! It works. It works. So negative 6, or positive 6 is our answer there. Ooh, number 4, don't forget to find the error there. What did they do wrong? What did they do wrong? Describe and correct the error. What did they do wrong? Describe and correct the error. Let's see. Number 5 is increasing, decreasing. Number 6, increasing, decreasing. And so basically, increasing, decreasing is from left to right. So always go from left to right. And it's x values only. X values only. Not the y values, just the x values. So from left to right, what are we doing right now? Right now, from left to right, even though the arrow is pointing down, we are actually headed, and from the left to right direction, we are actually going up. Yeah, so we're actually increasing until we get to negative 3. So from left, which is negative infinity, so we get to negative 3, We are increasing. So negative infinity to -3, we are increasing. Then we're constant from -3 to about 1. Mr. Newbold, why aren't you using brackets? Well, it's kind of tricky because at that point you're not increasing or decreasing. So we just use parentheses because you're just kind of stopped there. Yeah. Because that's where it changes direction. So we're constant from -3 to 1, -3 to 1. And then are we increasing or decreasing now? So now from this point from -3, so now from -3 to 1, we're constant. We're actually constantly the number 2. And now when we hit 1, we're going to go down. And so now we're decreasing from 1 to infinity. So thanks, guys. Have a good day. So give it a try now for number 6. Go ahead and give it a try. The hint I'll give you there is -4 is where it changes direction, as well as -3 is where it changes direction, as well as 2 changes direction. So give number 6 a try now. Number 7, 8, 9, 10, we're doing matching. So 2 to the x minus 1 power. Well, let's see. So if we did like maybe an xy table and plugged in some of those values. And so what if I plug in, let's see, what if I plug a 1 in? Well, 2 to the 1 minus 1 is 0. And 2 to the 0 power is just a 1. So it looks like we are at, so if we plug a 1 in for x, then we should be getting a 1 for y, which is not that one because that's a half. So it's not a. You plug in a 1, we should be getting a 1. You plug in a 1, you should be getting a 1. Oh, there it is. You plug in a 1, you should be getting a 1. So I'm thinking it's probably D, question mark. What do you think? Let's try another point on the graph. So as we go to the right, what's happening? What if I put a 2 in? So if I put a 2 in there, that would be 2 to the 2 minus 1. And so 2 minus 1 is just 1. So that's over 2 up 2. Over up 2, I think we found it. Well, if you plug a 0 in, you get 2 to the 0 minus 1. And so that's going to just be 2 to the -1, which is, flip it, is a half. Because that's 1 over 2 to the positive 1. And so 0.5. Yep, looks like we got number 7 is D. Number 7 is D. So number 7 is D. So you try number 8, number 9, number 10, use an XY table. Or you can go ahead and remember that. So you can always flip it and bring it down. It makes it positive. So 1 over 2 to the positive x. And so that might help you there, possibly, maybe. Ooh, this has a horizontal asymptote. Pause me, try it on your own. So horizontal asymptote of -4. Does that have a horizontal asymptote of -4? I think it does. Interesting, interesting. And then this has a horizontal asymptote of +1. +1 for number 10. So go ahead and find the rest of those, A, B, and C. Go and match those correctly. This one's just very calculator based. You just want to see if you can plug it into your calculator and round to 3 decimal places. So we're going to go to our calculator, get out your calculator, and you're going to type in 50 second. Where's E at? Do you know where E is? Oh yeah, it's down here. So e to the x power, do you see it above the ln? So you have to push second ln to get E. Second, that's the blue button, second, and then ln to get the E button. So 50 second ln, that gives us E, and that's E to the 4x power. But this time in place of x, what are we going to plug in there? So we're going to plug in a 0.02 in place of the x. And we get 54.164. So when x equals that, and you just go ahead and plug that in there, y equals 56.164. To 3 decimal places, did we do that right? Yeah, because the 3 does not round the 4 up, so we keep it like that. So there's our answer. So you try number 11, number 13, number 14. E to the negative x power, but you're going to plug a negative in. So that's e. Pause me. Try it on your own. I'm waiting. Pause me. So that's e to the negative 3/4, which is the same as e to the 3/4, which is the same as, hey, you could actually write that as a root if you wanted to. That'd be fun. You could write that as a e to the 3rd power and 4th root it. I wonder if that'd be the, yeah, it'd be the same. Okay, let's give it a try. So second ln, second e to the, and then 3 divided by 4th power. You might have to put that in parentheses depending on your calculator. You might have to put that into parentheses depending on what kind of calculator you got there, just in case. Okay, we get 2.117, 0, 0, 0, 0, 0. So when x equals that, negative 3/4, y equals 2.117, 0, 0, 0. And so that's just our answer right there. Don't worry about the zeros because we're doing 3 decimal places. Okay, good. Next page. Okay, so now we're going to be graphing. Do you remember how to graph 5 to the x power? So is that growth, decay, or neither, right, is what you got to think about, or negative growth, actually. And so let's go ahead and do 3 of those graphs to just show you. So an example could be y equals 5 to the x power, or y equals 2 to the x power. And so whatever your base is, if your a value is greater than 1 or greater, basically, not a fraction, so then it'll be something like this. Exponential growth. Yeah, exponential growth. And so this one would be growth because that's 5 to the x power. This one would still be growth, but you are shifted down to, right? Or you're down to, or you'd say your horizontal asymptote, right, is y equals -2. So that would be like down here, a -2. So 5 to the negative x, that's interesting. So write that over 1 and bring it down. So that'd be 1 over 5 to the positive x plus 1. And so you would have a horizontal asymptote at 1. That's your horizontal asymptote at y equals 1 because of this 1 right there. Let's match the color to remind you how that works. Right? So that's your horizontal asymptote. But those are going to be fractions. Smaller and smaller and smaller. Right? So I feel like if you plug in a 0, if you do an XY table, and you plug in a 0 in there, that's 1/5 to the 0 power. Right? So we're going to plug in a 0, sorry, for x. And so we plug in a 0 for x, and we get 1 over 5 to the 0 power plus 1. Well, anything to the 0 power is just a 1. So that's 1 over 1 plus 1. So if you plug in a 0, you're going to get 2. So you're going to be up here. And then what if you just plug in another number? Let's say you plug the number 1 in. So that would be 1 over 5 to the 1 power plus 1. And so that's 1 1/5. So that's going to be up 1 and a tiny bit. What if we go back 1? What if we go -1? Well, that would be 1 over 5 to the -1 plus 1. And that's going to bring it up to the top. And so then if you plug in an x equals 1, an x equals -1, sorry, then you're going to bring that up to the top, and it's going to be 5 plus 1 is 6. So that's going to be, let's see, -1, so back 1, up 6. Woo! So now you can see that this is decay, right? And that's because our a value, is, so we have y equals a. Let me see here. So we have y equals a to the x power, plus 1 basically. And so when your a value is less than 1, or even if your a value is between, right? If your a value is between 0 and 1, basically, if it's a fraction, then it's going to be decay. is going to be decay. And so, yeah, so it's going to be decay. Let's see. Let me see what else we can say there about that. So 1/5 to the x power, basically. Let me double check on that one, because I'm a little concerned about that one, just because it's so weird. So I'm going to say 5 to the negative x power. And then we have a horizontal asymptote of +1. Yep, that's decay. So this one is decay. And this one is growth. So if you do an xy table and you plug a 0 in, you get 5 to the 0. Anything to the 0 is a 1. So we get 0, 1. There's no value on the outside, so we have a horizontal asymptote at y equals 0. So it's just along the x-axis there, basically. And how do we know it's growth? Well, if you put x equals a 1 in there, that'd be 5 to the first power, which is a 5. So over 1 up 5. So that's some pretty good growth going on there. Pretty fast, actually. Woo! So pretty good growth going on there. There we go. Cool. Now, there's some other things to fill out. So again, the horizontal asymptote is just y equals 0 there. Just y equals 0. Because there's nothing in front, right? I mean, there's nothing after the equation. Plus 0. So this one has a -2, and this one has a +1. So that means the horizontal asymptote, the HA, would be y equals -2, right there. And this horizontal asymptote would be y equals 1. The domain. So as we go from left to right, it's going to be negative infinity to positive infinity, because there will be a value as we go to the left forever. And as we go to the right, forever. Just double check in. Yep, that's looking good to me. And then the range will be from 0 to infinity, but not including the 0, right? Because your horizontal asymptote, it doesn't actually ever touch it. So it gets really close to, not y equals 1, no, but y equals 0. So it gets really close to it, but doesn't touch it. So no brackets, oops, for the range, for the 0. No bracket, just parentheses. Because that's a horizontal asymptote there. So it looks like those might even match. Those two might even match. Right? Yeah, I think those will match. Okay, so then this one right here is 5x plus 2. So the plus 2 will just make it go bigger faster. And so if you do an xy table for this one, and you plug a 0 in, you get 5 to the 0 plus 2. And so 5 to the 0 is just 1, and 1 plus 2 is 3. So this is all the way up here, 3. Wow, that's really going to take off. And then if we plug in a -1, what happens? So that'd be 5 to the -1 plus 2. And 5, 2 minus 1 is 1. So at -1, let's see here, so at -1, so back 1, and we plug in -1 for x. 2 minus 1 is 1, so that'd be 5. What's going on there? Let me see. So that would be 2 plus the -1 is just 1. So at -1 we get 5. This isn't looking right. Let me see. Plug a 0 in, you get 0 plus 2. Oh. So we get 0. What's that? 0 plus 2. And 0 plus 2 is 2. And so then what is that? Let me see. So that's -1 plus 2. Okay, so then let's see. If you plug in a 0, you get 5. So 0 plus 2 is 2. And so that's actually going to be... you gotta put in parentheses. So that's going to be 5 to the 0 plus 2 is 2, so 5 squared. Whoa, that's 25? That's way off the charts. Up there, 25. So yep, we're going to come along this horizontal asymptote, and we're going to take off. So sorry, that one really takes off, right? So if you plug in a -3, for example, or maybe even a -2 next, that would be 5 to the, -3 plus 2. And so that would be, that'd be 2 plus 2 is 0, so 5 to the 0 is just a 1. So -2, yeah, right there, 1. We got it, we got it, we got it. Okay, so the domain will be from the horizontal asymptotes. No, the domain is negative infinity, positive infinity, right? But the range is what we're thinking of. And so that's going to be not including -4 because that's a horizontal asymptote. But -4 and then up to infinity. Okay, thanks for watching. And we'll do some more graphing on the next video. Thanks for watching. Thanks for watching and bye for now.